Welcome, this is Professor Bright, and this is one of the first videos for Math 1110 College Algebra at the University of Minnesota Rochester. So this video is just going to go over real numbers and absolute value and that general idea. Some sections may have not seen this in class, so that's why we're just doing this quick video. Last time in class, I know all the sections got through all these: real, natural, whole number, irrational, rational, and irrational. And actually there's another one that I don't have on this list, is integers, which are just your whole numbers, positive and negative. So negative 3, negative 2, negative 1, 0, 1, 2, 3, and it extends in both directions. Okay, and remember, I did say that sometimes you might run across some of these real number sets in terms of symbols, and so that's where the double bar R, double bar N, double bar Q, double bar Z come into play. So just be aware of those. Okay, now remember that the definition of a real number is any number that can be put on a real number line. Not the greatest definition in the world, but we're going to go with it. So just as a force of habit, when we draw a real number line, always include a line, that is to say a straight line or relatively straight, with arrows on both ends indicating that it continues in both directions, because real numbers do. And then, just for reference, I always have a habit of putting 0 on there just so everybody else kind of knows where we're centered at. It doesn't have to be centered, mine isn't, but just a good habit. And then if you have a real number, say like 2.149, put that on there with a label. Okay, no big deal. Now, when we talk about real numbers, we know that intrinsically there's some order. I put 2.149 to the right of 0 because, well, we know that positive numbers go to the right of 0 and negative numbers go to the left of 0. Yes. Why? Well, and that has to do with our definition of real numbers, in that when we indicate positive numbers, we say positive numbers have more value, and by default we put those numbers with more value further to the right along the number line. So that's why 2.149 is to the left of 0, and similarly if we had like negative 7, we would put it to the left of 0 because we say negative 7 has less value than 0. Okay, now the only other thing we have to really tease out is this idea of distance. So if I have these two numbers, and for simplicity I'm going to say that it's just 2 and 7, I want to know the distance between them. Well, okay, we learned this so long ago, and distance we can just say, oh, it's 9, right? Because there's 7 units here and there's 2 units here. Great, add them up, you get 9. Moving on with our life. Not really. The thing is that I want to express that total distance of 9. So here we're saying that distance is 9. I want to express that using the numbers that I'm given, so the negative 7 and the positive 2. Well, certainly I could just say, well, it is 2 plus 7, as is shown up here, right? And that's 9. That's not going to be sufficient necessarily, because I'm not using negative 7 and I'm not using positive 2. So what I'm going to do is say that, well, it is going to be negative 7, and then I need to do something with it, with 2, to get 9. Well, if I subtract them, that gives me negative 9, but then we remember this idea of absolute value. And when we do the absolute value, that only returns the positive. So positive 9. And so really what I'm saying here is that to get the distance between two numbers, doesn't matter what order you subtract them in. You could do 2 minus a negative 7. But either way, you end up with 9. And so when we want to communicate one-dimensional distance, okay, that's where we're going to use absolute value. Okay, turns out that this idea of using the absolute value for distance really only works in one dimension, because in 2 dimensions we end up with a different formula that we'll see later in the course. Alright, so that's just a brief recap on the number sets and real number lines and absolute value. Next video we'll introduce another type of notation that we're going to use when we're talking about real number sets.